Hey everybody, Mr. White here. I just wanted to go over a few of the concepts from today's lab. So I'm going to go ahead and do the trials and try to explain a little bit about what we're seeing. So we're going to start with our position time graph. And so position is on the y-axis, time is on the x-axis. We have the smart cart lined up with the starting point at 0 meters. And so the first trial asked us to basically not touch the cart. And so if I start that trial, or start the graph, and let it run without touching the cart, we see that we get a flat line along the x-axis. And that means that our y value is 0 and it stays 0. And y is position, so that's telling us our position is 0. It never changes. And that makes sense, right? Because we haven't moved. We are staying at position equals 0, which is where we're starting at. The second trial asked us to move the cart forward slowly from 0 to 50 centimeters or 0.5 meters. And you can see the 0.5 on the y-axis. That's 0.5 meters. So eventually our line will get to 0.5 meters over a certain amount of time. So I'll go ahead and run that one. And so we can see that the line starts to climb towards that 0.5 meters. And so if we focus on around where time equals 2 to time equals 6, where I was actually moving the cart, we can see that that line slopes up towards that position equaling 0.5 meters over that time from time equals 2 to time equals 6. So it took about 4 seconds to do that. The next trial, reset the cart, and the next trial asked us to do something similar, except this time we're moving the cart backwards. And so I'm going to have to walk over there, so I'll start the trial, and we're going to move the cart backwards to 50 centimeters, or 0.5 meters, and then we're going to stop. And so if we look at the graph from about time equals 1 second to time equals about 5 seconds, we can see that now we have a sloping line, but it's sloping down. And that's going to negative 0.5. So you'll remember in our first run, we had a flat line because we didn't change position. In our second run, we had a positive slope towards 0.5 because we went forward. And now we have a negative slope going to negative 0.5 because we went backwards. And so we can start to see the relationship between the positive and the negative in the direction that the cart is traveling. Positive, in this case, is meaning the cart's going forward. Negative means the cart is going backwards. All right. So trial 4 asked us to move the cart forward quickly. So let me reset the cart at our starting point of 0. And this time I'm going to try to move the cart really quickly to our 0.5 meter or 50 centimeter mark. And so we can see when I was moving the cart, and I guess I didn't quite get to 0.5. Let me run that one more time so we can try to get a little bit better data. So reset the cart and start and really quickly to 50. There we go, that's a little better. All right, we can see that we still went to 0.5 meters on the y-axis, so our position still went from 0 to 0.5. But notice how the line is a lot steeper. So what changed between this one and our first run going forward, where we still ended up at 0.5? Well, we went faster. And so if we look at this in terms of the variables, we have time and we have position. Well, in both cases, we got to 0.5 meters. But when we went faster, we got to 0.5 meters in a much shorter amount of time. So in our first run, you'll notice that we took from time equals 2 to time equals 6 about 4 seconds to get to 0.5 meters. In the run we just did here, you'll notice that we got to 0.5 meters in about, well, it looks like a little less than a second. So it took less time to get to the same position, and in order to do that, we had to move faster. And so this shows us that our slope is giving us our speed. Alrighty, our last trial, trial 5, we were asked to move the cart from our starting point at 0 centimeters or 0 meters to 50 centimeters or 0.5 meters, and then back to our starting point of 0. So I'm going to go ahead and start the trial. And so keep an eye on the graph. And so we're going to move forward, and we see that positive slope like we expect. And we get to 50, and now I'm going to go backwards, and we see that negative slope when moving backwards. And now I'm stopping at 0, my starting point. And so taking a look at the graph, we see that positive slope, and then when we get to our 50 centimeter mark, we see the curve round out and start to go back down. And that's when we get back down to where position equals 0. And so we end up with that kind of hill-looking graph. And this is important because we were asked in the analysis questions if displacement and distance are always equal. And they're not, because if we look at the total distance that the cart travels up to 50 centimeters here, and then travels back another 50 centimeters to the origin. So that's a total trip of 1 full meter, or 100 centimeters. But the displacement is 0, because displacement is comparing where the cart starts from and where it ends. And if we look at the point where it starts, compare it to the point it ends, they're the same point. And so there is actually no displacement. There's no distance between the 2 points because they're the same. And so in this case, displacement is 0, but distance traveled is 100 centimeters or 1 meter to answer that analysis question. If you have any further questions about any of these concepts, please ask, post comments, come see me in class to get some help, extra help. I can make an appointment with you. But I do want you to understand these concepts, so hopefully this video helped. But again, ask for help if you need it. Alrighty, I'll see you in class, and have a great day.